a couple different types of equations so far. We've done equations where we had a log and we used the definition to rewrite it as an exponential so we could solve. We've done problems where we were able to get a common base and solve. We had problems yesterday where we couldn't solve with common base, so we added a log to each side to solve. Today, I want to look at problems that have multiple logs within them. And how do we solve this? So, yesterday our strategy was to add a log and then use our properties of logs, right? The log's already there, so we are going to try to work backwards. If I'm looking at this, what would we do with this 2?
Oh, be an exponent.
So that's log base 5 of x squared equals log base 5 of 9. What do you think we could do right now? Drop the logs. We have a log on each side. Yesterday we added it to each side. Today, if they both have it, we could take it away. We have a single log on each side, so x squared equals 9. Okay, so then, how do we get rid of a square?
Square root.
Anytime you add square root, you need
Plus or minus.
Okay. Then at the end, we just have to check, because remember, with logs, the argument has to be positive. Both the base and the argument have to be a positive number. So, is it okay for x to be a 3? Yes. Is it okay for x to be a negative 3? No. So 3 is my only solution here. Let's try another one.
No, that's my mindset today. I can do it. That's my mindset.
She's doing the math.
Okay.
Okay, so you hate me.
Okay, go ahead, stop talking.
What would I do on this one?
Guys, am I getting clogged? Yeah.
Okay.
Well,
Take my 3f. Alright, if that's all I do, I can't drop my logs yet because I don't have just a plain log on each side. When I'm looking at this, there is a negative in front. That's the same thing as saying a negative 1. Where would that negative 1 need to go? The exponent. So I'm going to write this as log base 2 of 27 to the negative 1 power. All right. From here, now we have a single log on each side, so we can drop it. So x cubed equals, what is 27 to the negative 1? To get rid of a cube, we cube root. Do we need a plus or minus? No. Odd roots don't need it. Even roots do. So we get 1/3. Do a quick check. Just make sure if I plug in 1/3, is my argument positive? Yeah. If it wasn't, what would my answer be?
No solution.
No solution. Good. All right. So far, so good? Let's look at this one. All right. How is this one different than the last problem? We have couple different things. We have multiple terms in parentheses. We have 2 logs on the same side. Does this side have a log? No. Okay, let's just start with our properties of logs. If you have 2 logs being added, how do you put them together? Do log base 5. Can I go ahead and multiply these? Is that okay? So I have to FOIL, so that would be x squared plus 2x and plus 6x would be plus 8x plus 12. So we had to multiply together those arguments. Okay, can I just drop the log here? No, we can drop it if there's one on each side. There's not. So then this is like the problems on our last quiz. There's a log on one side. What did we do? We changed it to exponential. You start with the base. The base of the log becomes the base in the exponential. Go across the equal sign. So 5 to the first power is equal to x squared plus 8x plus 12. 5 to the first is just 5. What would you need to do now? All right. What multiplies to 7 and adds to 8? If I set those equal to 0, we get -7 and -1. Now, we don't just assume that negatives don't work. We have to check. We're making sure that the arguments are positive when I put these back in. So if I, look up here, if I plug in a -7, is -7 plus 6 positive? No, so -7 doesn't work. Let's try -1. -1 plus 6 is positive. -1 plus 2 is positive, so -1 works. Questions? You guys think you could try this one? So you start properties of logs, condense these by multiplying. You have to FOIL. So we get x squared plus 15x plus 56. Then, since there's only a log on one side, you have to do the definition. So 2 to the first power is x squared plus 15x plus 56. 2 to the first is 2, so subtract that over. What multiplies to 54 and adds to 15? Set those to 0, we get -9 and -6. We always have to check. All you have to verify is that they're positive. If you put in a -9, that is not positive. If I put in -6, -6 plus 7 is positive, -6 plus 8 is positive. So -6 works. Because you subtract.
Which you always have to,
Well, if it's
unless it's a negative. So we're
So
not,
it does have like a -54, you can add a positive to each negative. Because it's
oh,
positive.
my line is odd.
Alright. Let's try this problem. Okay, what would I do with my 3? Then, if these logs are subtracted, how do we combine them?
Divide.
The x minus 1 cubed divided by 4 equals 5. You have a log on one side, so how do we get rid of it? Change it to exponential. You have to know how to do that. You always start with the base. So that's the base of your exponential. Go across the equal sign. So 2 to the 5th power is equal to x minus 1 cubed over 4. 2 to the 5th is 32. So we can multiply our 4. How do I get rid of a cube? Cube root it. I don't think that works out perfectly. We're going to give a decimal anyway, so I'm just going to hold off a second before I plug that in. What would be my final step for getting x by itself? Add 1. So we have the cube root of 128 plus 1. So if I put that in my calculator. So I get 6.0397. Check it. If I do that, minus 1, it's positive, so we're okay. So far, so good. We're going to do a few more examples to make sure we've got it. I don't have any other tricks up my sleeve. We've done everything. So we'll do 2 or 3 more problems and make sure we're okay before I stop.
Oh, I just. Okay. Okay.
You'll notice I have 2 logs. Can I combine my 1 with the log? No. So I should rearrange it so all the logs are on one side. If 2 logs are being subtracted, how do we put them together? What do we do? Exponential. If there's not a base written, what do we assume? It would be 10 to the first equals 2x plus 1 over x minus 2. All right, 10 to the first is just 10. If I'm trying to solve this, we would have to multiply the x minus 2 to the other side. So then I could subtract over my 2x. Add over my 20. So 8x equals 21, so x is 21 over 8. Okay, if I plug that in, times 2 plus 1 is positive, minus 2 is positive. So that one works. All right. Nice. Do you guys want to do it together, or do you think you can try it? You can try? Okay. I saw two different ways of working this, and they both work. When logs are added, you multiply the arguments, so you get x squared minus 4x. A few people also subtracted this one over, so all the logs were on one side, and they divided and made it over x plus 6 in the argument, which is fine. At that point, if you did it that way, you have to change it into exponential. If you did it this way, now you have one log on each side, so we can drop that log. So if we get it equal to 0, it'll be x minus 6, x plus 1. So x is 6 and negative 1. And then we check, 6 minus 4 is positive, 6 is positive, 6 plus 6 is positive, that one's good. Negative 1 is not. So 6 is the only answer that would work. All right. Let me try another one. The best for last.
You're laughing at me.
Alright. This looks fairly ugly, but let's just take a second, deal with one side of the equation at a time. These logs are being subtracted. How can you combine them into one? Division. So this is log base A of x minus 1 over x plus 6. Over here, I have logs being subtracted. So we again do division. Log base A of x minus 2 over x plus 3. Now what? We have one log on each side, so we drop it. So if the log is on both sides, bless you just drop it. If it's only on one, you have to change it into exponential. How do we solve this problem now? So when you do that, you have to FOIL. So that would give me x squared is 2x minus 3. And this one, I get x squared plus 4x minus 12. Look at how nice that is. When I subtract my x squared, what happens? Cancels out. Okay, if I want, I can subtract over my 4x, add over my 3. So we get negative 2x equals negative 9. So 9 halves or 4.5. Check, if you plug 4.5 in, are all 4 of these arguments positive? Yes. If even one of them turned out to be negative, it would just be no solution. I have more problems. Do we need more? Okay. So we have about 20 minutes left. I want you guys to work in class so you can ask questions. So remember yesterday I posted the 4.5 assignment. We're on day 2.
I have